Assalamualaikum and hi everyone, we are from Group 7 and today we'll be presenting on parallel merge search. Let me introduce my groupmate first. I'm Najwa Alina and with me are Umi, Elisa, Shaira, Ada, Fatin and Yasmin. First, parallel merge search is an enhanced version of the traditional merge search. It uses parallel processing, which means multiple processors sort the data at the same time, but the algorithm still follow the divide and conquer method, which is dividing the arrays, sorting the part in parallel and merging them back together. It achieves parallelism in two stages. First, during the sorting phase, different processors handle different subarray. Then, during the merging phase, the sorted array are combined in parallel. This greatly improves speed, especially for less data sets. With that, let's move on to the next part, which is about word and span.
Word denoted as T1 is the total of primitive operations an algorithm performs and represents the time it would take on a single processor. It measures the overall computational workload. Span, or T infinity, is the longest sequence of dependent operations and shows the minimum time required using unlimited processors. It highlights the parts of the algorithms that must be executed sequentially. The ratio T1 over T infinity represents the maximum theoretical speedup of an algorithm and indicates how well it can scale with parallel processing.
Explain the Sudoku for parallel merge sort based on the explosion execution model. This algorithm uses the divide and conquer method. It keeps splitting the array into smaller parts until each part can be easily sorted. Then it merges them back together into one sorted array. To make it faster, this version runs in parallel, which means it lets different parts of the algorithm run at the same time using multiple processors. This is done using two key commands, spawn and sin. Spawn is used to start sorting one half of the array in parallel. Sin waits until both halves are done before continuing to merge. This merging part is where two sorted arrays are combined into one. How many steps it takes by increasing a work counter. This counter shows the total work, or T, which is the time it will take if only one processor was used. At the same time, we also track the span, or T, which is the longest chain of steps that must happen one after another. Even we had unlimited processor, this is counted using a spawn counter. Finally, in the main function, we test the algorithm with an example list 12, 4, 19, 2, 7, 5, 1, and 8. After sorting, it prints the final sorting list, the totals, the total work, the span, and the parallelism ratio, which is T divided by T. This ratio tells us how much speed up we can get if we use a lot of processor. So overall, this pseudocode helps us understand not only how merge sort works in parallel, but also how we can measure its performance using work and span.
Assalamualaikum, I am Elisa Shafar. I will briefly explain about the theoretical calculation of parallelism using merge sort on an array of 8 elements. So first of all, we need to calculate the total work, which is the total number of operations if done sequentially. Merge sort works in big O and in bracket n log base 2n in here, n equal to 8. So T1, just substitute it into the formula. T1 equal to 8 times log base 2, 8 equal to 8 times 3 and equal to 24 operations approximately. Next, we calculate the span T infinity, which is the time taken in the best parallel case, which depends on the depth of recursion. T infinity equal to log base 2, 8 and equal to 3. And lastly, we find the parallelism. We divide T1 by T2, which is total work, divide by span. And we just calculated just now, 24 divided by 3 equal to 8. So this means we can ideally run this algorithm 8 times faster in parallel compared to running in sequential.
So I'll explain about parallel merge sort recursion tree. So this diagram show how the merge sort algorithm works. The first one is the array is split into smaller subarrays until each one has only one element. And the second one is each subarray is then merged back together in sorted order. And the last one is the process follows a divide and conquer strategy, starting from the top and going down then back up. So the key idea will be split, solve, and merge.
Amdahl's law is a formula used to predict the potential speed up of the system when the specific part improves. It shows how much faster a task can be complete when more resources are added to the system. This is formula for speed up, which is 1 over 1 minus p plus p over n, which is p is parallel portion, 1 minus p is serial part of the job, and n is the number of processors. Span represents the minimum time required due to sequential dependency, and the formula for parallelism is T1 over T infinity, which T1 is total works, and the T infinity is the span.
In parallel computing, the maximum theoretical speedup is limited by the span, the longest sequence of dependent steps that must run sequentially. It's calculated by dividing total work by the span. For example, if total work is 40 and the span is 3, the maximum speedup is 13.33 times. However, a true speed up is usually lower due to overheats like precreations, synchronizations, and communications delay. The span set a lower bound on execution time. No matter how many processors are used, according to Amdahl's law, the serial part of a task limit overall speed up. To improve performance, it's crucial to reduce the span and minimize system overheat.